So, welcome to chemistry. I just realized the other question that has come up that I forgot to mention here and I forgot last night. Part of your grade is attending every week, and I don't know how I worded that on your syllabus. You're each going to figure out, excuse me, what that means for you. So some of you are going to find that is office hours. Some of you are going to find you want to be in lecture. Some of you are going to find both of those. And again, I have office hours on Tuesday, Thursday evening. Thursday is by appointment. So if for something comes up, like somebody had texted me and they had an emergency, I have actually somebody in my other class whose wife is delivering a baby right now. So they're obviously not going to be here. All right. So if you have the notes, that's wonderful. If you don't, just write on notebook paper. And if you have a question as I'm going along, just push the space bar and please ask because somebody else has the question, I am sure. So our question is, what is chemistry? So usually I do a half-hour, 45-minute PowerPoint talking about the history sum of chemistry, and I actually did that on PowerPoint and I posted it. And so that is part of your lab, is to watch that, and then whatever in it inspires you. So it could be about the elements, it could be the elementals, it could be Dmitri Mendeleev. So just a paragraph about your thoughts or your thoughts about chemistry and your hopes for the term. Does anybody know what chemistry is the study of, or what they claim it's the study of? Nobody wants to speak because we're in Zoom. I found that in the classroom, then in Zoom, everybody's still hesitant to talk. And actually, sometimes over the first few weeks, people become more responsive. Chemistry is the study of matter, which is actually my hint as to why, what is matter. But matter is the physical stuff. You don't actually have to write this down. It is the physical substance of the universe, which is completely a myth. And that's where we get into quantum mechanics in the next couple weeks. In the video on the history of atomic theory, I talk about that the definition of chemistry is the study of matter and the transformation. And so chemistry is a study of transformation. Transformation meaning chemical reactions. We do get to that eventually at the end of the term. We have a lot of building blocks to go before that. And which is really cool. I had a friend who many years ago when I was actually went to school for acupuncture also. So when I was in acupuncture college, a friend said when she was doing her undergrad, her first term, she actually had physics and transcendental meditation, the same term. And about halfway through, she realized they were the same class. They were teaching the exact same things. And so that's one of the things that's fascinating. So chemistry is the study of the physical stuff of the universe, because we decided that we are physical beings. The thing that we'll get into, I mentioned in the video, and we will get into when we get into the quantum world. I think I have a quote on your syllabus that, no, I don't. I took it off. So I had to redo your syllabus. We're actually all vibrational beings. So if you get inside the atom, inside the protons and neutrons, and inside of everything, we're all just vibrations. And it's the vibrations that create our reality. And everybody's creating this very interesting reality. So, yeah. All right. We're going to talk about how to classify matter. I usually do a really cool demo here. I mentioned this in the video. I have to go through a lot of red tape to be able to go to school and do a demo. And I went through the red tape and I was there getting ready, and another person came in and wanted to use the lab at that time. And so I will eventually videotape the demo for you as part of our lecture. So matter, we're going to classify it here on this first page for this first little bit. And your first study set just has some questions with this. It's just a place to start to talk about chemistry. you can classify it as physical or chemical. Those are our two choices. Or how chemists, this is like the duality of everything, right? Physical or chemical. Physical just means something you can sense or measure. So a measurement would be like distance. So can we put a unit on it, like mass? If I had, oh, I don't have, we can get my gnome. Or I usually have something in the classroom and I just realized. So, oh, my gnome is pretty big. I have to find the little gnome. Oh, I can't take my gnome apart. Here we go. We'll do part of a gnome. So there's our gnome. That's what a gnome is. I talk about a gnome in the video. The little gnome fell somewhere in the room. So he has a certain size, he has a certain mass, he has a certain color, he has a certain height. All those things are physical properties. He smells like a gnome. He smells like nature, because gnomes are very much, they do all your gardening and stuff for you. So senses. So the act of smelling actually has chemical reactions going on, but the smell of something, if we took, I usually do this with a gummy bear. And so the gummy bear is a certain size, a certain mass. He tastes like high fructose corn syrup. He's super sweet. So anything you can sense or measure is a physical property. With that, density. There's a couple key ones, and that's why I have the list here. Density is mass per volume. And it's something we will talk about. There's a good half-hour lecture, and we do a bunch of math with it. It's a measurement that chemists use a lot. Solubility. So does something dissolve or not? That is actually a physical property. Has to do with if they're polar or non-polar. So do they have an equal distribution of the electrons within them? Magnetic. So if something is magnetic or not. If something is metallic. Again, I usually write on the board, so I have a lot of space, and so I'm limiting myself. So all those things, most properties are physical properties. Chemistry is really special because a chemical property, you change what it is. It is a reaction. It is reactivity. And chemical reactions are dramatic and exciting. Sometimes they're not that dramatic. But an explosion would be an example. Or of something not reacting is also a chemical property. And we actually change its identity. What that means is if we took C6H12O6, which is sugar, that's actually your blood sugar. This is what's going on in all our bodies right now. And we're all breathing oxygen. Now, this is a beginning chemistry class. A lot of you have never had any chemistry. I actually assume that half of you have never had any chemistry before. I assume everybody's had no chemistry. These are symbols from the periodic table. So I have to, it's working so much better. But I have tons of periodic tables in here. I think I posted one. And we'll talk about more next week. We have a lecture about the periodic table. But when I think of chemistry, this is what I think of. This is actually when I've been in class for 25 years, this is the periodic table that I give out to my class. And I haven't posted it. I might after the first midterm, I haven't decided. It has numbers. You're gonna always have a periodic table. You're going to want to find one that you want to print. The one I know I posted it with my other class. It might be next week I'm going to post it for you because we're going to do a lecture on it. What's missing from this one are the names. And I'm going to tell you this. I would prefer that you learn the names because you're going to hear me talk words like carbon, calcium, sodium, but you're going to see me writing in symbols like this. And so this is carbon, hydrogen, oxygen. You want to get where you're comfortable. Now with that, half of you are going to have a periodic table with names. You might as well all have a periodic table with names. So OMSI, so our museum downtown, has, somebody got me this placemat, and it's really nice because it's laminated, so you could write all over it, but it does, the names are little. Don't become dependent on the names. The first 36 elements up through Krypton are actually, yeah, my screen's not big enough to show this whole table, but the first 36, you're going to hear me mention every single one of them here and there. Do you need to memorize the order? No, you don't need to memorize the order. You're going to always have one in front of you. The names on there should be a backup in case you can't remember, but that was why my email, to try to get you to start learning your names. So when you see me write symbols like O, that you're not panicking, you're going, oh, that's oxygen. I'm pretty sure you all knew that was oxygen without me saying. And the C, of course, stands for carbon, and the H is hydrogen. These little subscripts, they are there because that is how many of each atom are in this compound. So there's 6 carbons, 12 hydrogens, and 6 oxygens. We're going to build our way up to writing the compound structures and stuff, but I do mention it the first day because it is chemistry, and we want to, yeah, we want to do that. All right. So this is going to react in our body, and we have CO2 and H2O get formed. So CO2, we breathe it out, that's carbon dioxide because there's 2 oxygen, and H2O is water. Hopefully you all knew that the symbol for water was H2O, but if you didn't, there you go. You don't need to remember it. Well, actually you should. That should be one of the things you knew coming into the class. My equation's not balanced. We'll worry about that in a couple of weeks, but that's what a chemical reaction, that these guys are arranged in a way, they're hooked together, they're stuck together. The carbon, what's going on here is the carbon has electrons, and your oxygen in the air is extremely greedy, and it wants those electrons. And so it's stealing the electrons from the carbon and the hydrogen, and that's how this rearrangement happens. So now the carbons are hooked to oxygen, and the hydrogens are hooked to oxygen, and everything's honky-dory. And so that's what we do. And then the trees were designed so they take in the CO2 and the water from their roots, and they make us oxygen and glucose, carbohydrates for us to eat. All right, so we're going to go through these examples. Again, if you printed, you'll be able to follow along. If you didn't print, just make the notes, especially things I point out, and say, oh, I can go back and look at it. All right, so this first column, or actually A through H, is all about Cl. Does anybody know what Cl stands for?
Chlorine.
Thank you. Yeah, it stands for chlorine. So on this periodic table, this one doesn't have the names. So the symbols on the periodic table, some of them only have 1 letter, like oxygen, nitrogen, carbon. It's always written as a capital letter. If they have 2 letters, the first one's capital and the second one is lowercase. So it is chlorine. And let's talk about it. So chlorine is a gas. So that was another thing for physical, solid, liquid, gas. Yeah, when I put my hand under this, it changes the focus, sorry. All right. So if something's a solid, a liquid, or gas, and the transformations between a solid, liquid, and gas, those are physical. So if you take water and you heat it until it becomes steam, until it's completely water vapor, it's still H2O. You have not changed the chemistry of it. You just changed the state of matter. So that was no chemistry happening. That was just a physical change. All right, so this is physical. You can write P for physical, like I said. It's heavier than the air. That means it's denser. This was a problem during World War I when they were using chlorine gas. It would sink into the trenches, and then the guys all asphyxiated because they didn't have oxygen, and the chlorine was toxic to their lungs and blinded them and stuff. And we banned chemical warfare. It's also believed that the flu epidemic 100 years ago in 1919, 1920, was actually a result of the use of the chlorine gas in World War I. So fascinating. Makes you wonder then what this epidemic is from. There's a lot of thoughts out there about that. All right, color, physical. It stinks. It's like you don't want to be anywhere around chlorine. So physical, most things are physical. All right, E. E is finally chemical. So the word burn means reacted with oxygen. You probably all did this at some point in your life. You lit a candle, you lit a match, whatever. Burning means plus oxygen. Oxygen has to be present for something to burn. It's what the terminology means. And so it means a chemical reaction. If something does not burn, that is also a chemical reaction. So in the case of chlorine, chlorine and oxygen don't react. Now, there are some reactions they do. They are man-made reactions, but in nature, they don't react. They don't want to be together. All right. Chlorine, on the other hand, reacts very aggressively with sodium. Your teacher, unfortunately, did that experiment one time unintentionally. I did not fully react a piece of sodium and put in a waste bottle that had some chlorine, and we got this huge fireball. It only lasted less than a second. And it was actually a young gal was standing there when it happened, and me and her just stood there. Our eyes got bigger than the deer in the headlight, and everybody in the class could feel the fireball, and all the guys whipped around, and they're like, "What did you just do? Do it again, do it again." And I'm like, "No." And 10 years later, I did it again by mistake. So we're on the 10th year anniversary of that mistake, so I'm up for doing it again. Don't recommend it. All right, boiling. Boiling is just changing states of matter, so that's physical. Look at that, it's really low because it's a gas. Solubility, I talked about, that's physical. And this is still about chlorine. Carbon filters will remove it. That is physically removing it. So most things are physical. All right, let's do the next column. So PB is on the periodic table. It does not stand, it's number 82. There we go. It does not stand for peanut butter, although that is the joke many people make. My peanut butter in my house is labeled as PB. It is an ancient one. It has the Latin name. We're going to use the English name. The Latin name, does anybody know the Latin name? Has anybody ever heard of a plumber? Or has anybody ever been fishing and that piece that you drop down, or to have a plumb line? So it's called plumbum. Yeah, and so that's why where the word plumber comes from is in ancient Rome. They made these amazing plumbing systems, and they made it out of this element. This is lead, and lead is a heavy metal, just like Hg. Does anybody know what Hg is? Hg is mercury that a lot of people put in their mouth, and mercury and lead, they bind to your brain, to your neuroreceptors, and then they don't work, and you go crazy. And the Roman Empire pretty much did go crazy. They did a lot of crazy, bizarre stuff. And so the heavy metals, yeah. All right, that's why it's called a heavy metal. I'm pretty sure like ammunition, it's hunting season right now, and the ammunition has actually changed because the amount of lead that some people were saying was going into the environment. So that's a whole nother can of worms. You know what? I just remembered something that about your syllabus, and talking about lead and chlorine reminded me of this, and I'm gonna mention it. I don't know if any of you noticed, it is on a Thursday, but this is absolutely negotiable. We'll worry about this in the 10th week. Instead of another exam, you guys are going to do a paper on an element on the periodic table. So it could be lead. You could be like, oh, I want to learn more about what the Roman Empire did with the lead aqueducts. Each student gets a different element, and you're going to write a short paper, like 3 pages about it. a little bit about the history, a little bit about the uses, anything cool about it, and you're going to do a Zoom presentation, like a 3 to 5 minute presentation. I've done this with my classes, and it actually works really well on Zoom. For those of you who are going to be teachers, this actually works really well for students to do presentations. My class this summer, everybody had to do 2 presentations, and it was so fun. Everybody's anxious, so don't drop the class and say, oh my God, she's gonna make us do a class presentation. It ended up being the highlight of the term for everyone, especially students who were the most nervous. Some of the quietest students who never said a word in class, they gave the best presentations. So you're all gonna pick an element. You can let me know at the end of class. You have until Thanksgiving to pick your element, so don't panic about it. There's lots of elements. There's about 25 of us. So anyway, pick something you don't know much about. So we're going to talk about plumbum or lead. So this is the color, and it's a solid, so that's physical. Does not dissolve, that's physical. Poor conductor, conductivity is physical. Density is physical. Oh, we get to that word oxidize. Oxidize means it reacted with oxygen. It's a fancy word chemists do. We actually spend a whole week talking about oxidation. In my humble opinion, that is one of the most important concepts you get from this class. Somebody said they were going into naturopathic medicine. Somebody else, a lot of you are going into medicine. Some of you are going to engineering. What drives chemical reactions is a lot of things, is oxygen's greed for electrons. What makes us sick is oxidation. And so crappy food is an oxidation hell. This is chemical. All right, melting point is physical. Soft, malleable. Malleable means it bends. You can pound it into shapes and stuff like that, but malleable means it's basically it's soft. So those are physical. It's not magnetic. Those are physical. So again, some of you did not print notes. You don't have to ever print notes. You feel like there's a lot of writing. Please realize right now you can't stop me easily, but you can always go back and watch the video. And also if you miss a class, please realize you can always have the video, which nobody ever had before, or my class never had. All right, and then this word, an alloy. An alloy is a physical blend of metals. So it is physical. So if you look at that, pretty much everything's physical. Chemical reactions are special because they're transformative. So, all right, questions? I have my clock up there. That's why I keep looking that way. All right. This is another way to talk about matter. And again, matter is the periodic table, the building blocks of matter. If you believe that, that's our belief system right now. And so that's what I teach, and we go with it and have a lot of fun with that. All right. Pure substance. When we do the homework is going to have this beautiful, grammatically somewhat correct statement about what a pure substance is. It's like a true-false question. You're right now having a teacher in a Zoom environment, first day, and I have to say this, Omar, your picture is like what I see right now. It's just the order it is on my screen. But when it records in a different order. I don't know why. And I absolutely love that picture. I absolutely love the hairdo. Anyway, so it's keeping me smiling. So you should always be at the top of my list on that. You still have really fun pictures that you can put as your, when you become a dark box. All right, like the raven, I really like that one. A picture that identifies you. It doesn't have to be your picture. It could be something that you identify with, and it can be something different every week. All right, so like for me, it'd be chocolate this week. Omar, were you gonna say something?
Do like every chemistry, that's the base, you know.
You even have the accent that goes with it. I mean, it's awesome. All right.
Thank you.
I'm gonna do a mixture definition because that's what's coming to my brain right now. It's been a year since I've had to give the definitions, and so I'm trying to find the neuron. And so sometimes I just babble to allow the neuron to find its way. I have to do the Dumbledore thing and find the memory. A mixture is a physical blend. Look at that. I just wrote that. Physical blend of two or more substances. Two or more stuff. An example would be air. Air is a physical blend, right? It's mostly nitrogen and oxygen. There's CO2, et cetera, et cetera, et cetera. It's a whole bunch of stuff. Everywhere you go, it's actually slightly different. So if we go to like Los Angeles, there's going to be a bunch of smog, so nasty stuff in the air. Oh, like 2 weeks ago when the fire happened, the fires were going on, it was definitely nasty. This morning when I went outside, it wasn't a skunk, but it was a raccoon or a cat, and heat had skunked my backyard, and that smell that is not very pleasant. So it has a sulfur smell to it. Another example would be tap water. So tap water has extra stuff in it. They used to actually bottle our water. We get it from I was just there the other day. I can't remember the name. But our tap water is beautiful here in East County, except then they chlorinate it. So there's extra stuff in it. I know when I went to Southern California like a decade ago, have no desire to go back there really. Their water was awful. It was, and when I go to New Jersey, my mom lives in New Jersey, and so I go to visit her twice a year. Their water, it takes me a couple days to get used to drinking it. I mean, she has a filter system on it, but there's still a different taste. And when I had the chance 10.5 years ago to be in the Himalayas, so it was just fresh water. It was so wonderful. And you're also then getting all the minerals from the Himalayas. And it was really interesting. All the Europeans that we saw there, they would be filtering the water. And so my last name is Sherpa. Sherpas are the people who climb the Himalayas. So my son Joey, his dad is a Sherpa. So that's where my last name's from. And he just also was in disbelief. He's like, why would you filter? Once you get to a certain elevation, the water is beautiful. All right, a pure substance is pure. It is one substance in a fixed, that's what it is. It's a fixed composition. So like tap water, it's going to be different everywhere you go, a different blend of minerals and stuff. Pure substance would be like pure water. H2O is a fixed composition always of 2 hydrogens and 1 oxygen. If you had like CO2 versus CO. CO2 is carbon dioxide, it's a carbon with 2 oxygens. CO is carbon with 1 oxygen, that's carbon monoxide. That's going to kill you if you breathe it in, right? Because it binds to our hemoglobin. So it's a fixed ratio, a fixed composition or ratio. We'll say fixed composition. Under pure substance, I did not give you enough space for those of you who printed, because I think maybe you write smaller and more elegant than me. There are 2 types of pure substances. There are compounds and there are elements. And I bought different colors so I could do this in different colors, and I keep forgetting that. So now that I remembered, a compound is what I've been doing mostly. It's made up of 2 or more elements in a fixed ratio. So CO2, H2O. An element is periodic table. An element cannot be cannot be chemically broken down. I want to make a quick disclaimer. We moved 100 years ago into the subatomic world. moved into the atomic age. And so that's nuclear chemistry, but in simple chemical reaction, you cannot chemically break down an element. You cannot, this was a statement to say you cannot change lead into gold. So you can't chemically change an element. A compound, you could chemically change it. So the CO2 could be changed to CO. All right. Another definition of pure substance is, and I don't ask you for these definitions, this is just to help you as we go through the practice. The way you're going to see the questions or give me questions is you would just see a list like this and you'll tell me, is it a pure substance or a mixture? Is a pure substance cannot be physically separated. So you cannot physically separate. A mixture you can. So CO2, we cannot use a filter and physically separate the carbon and oxygen. You need a chemical reaction to separate the carbon from the oxygen. All right, one more piece before we go with this, and I'll write down here. When we talk about mixtures, so this is under mixtures, you can have homogeneous, I know, so, and heterogeneous. I'm giggling at myself because there's a lot of words the first day. And usually what I do after we get through this page is I usually make the class ice cream. And so AJ, the other AJ, and Tyler, several students have been sending me messages from previous years going, so I guess we're not making, because they would come in and help me make ice cream for the class, and we would use liquid nitrogen, and so we could make ice cream in under a minute. And so I would make it actually, it would be no sugar. I'd use dates and coconut milk or avocados. I know it sounds weird, but it was great. And local berries. All right, so you can imagine that. So after having all this tedious, so all the students, and then I would do a really cool demo and you'd see flames and colors, and everybody just thought I was the greatest teacher ever and forgot all these words. And so I'm giggling because I just have this page that has all this information, and there's always some student who's like, oh my gosh, that was so much. You have to trust me. That it's not as bad. It's really not. This is the first day. This is a new subject. These are just words. You're going to hear me do them over and over. As long as you do the homework and the work, you'll be fine. All right. So the prefix homo versus the prefix hetero. Homo means same, and hetero means different. So in the terms of this, it means when you look at it with your eyes, so it looks the same. So if you look, we'll look at it with examples. A chocolate chip cookie. You can see all the chocolate chips. So that would be heterogeneous. This is looking with your eyes. So please be careful because we can get the best microscopes out there. And when you start, that's one of the videos you get to look at. Everything is made up of different things inside of them. This is with our eyes as humans, not gnome eyes, not a microscope. So let's just, pure substances are always homogeneous. So I just ask if you, we're going to classify here. If you classify as a mixture, you will tell me if it's homogeneous or heterogeneous. So you can write HM and HT. That's how you'll see me. Just write HM and HT. And mixture, compound, or an element. And you can just write mix. You don't have to write the whole word out. Learn how to abbreviate. That will make it a lot easier. All right. So a chocolate chip cookie with or without nuts. Usually I love baking. So usually I make treats for the students, and we don't get to do that right now. But this is definitely a mixture. There's going to be different types of flour in there. There's the chocolate chips. I throw in cranberries. I always throw in extra chocolate. There is some kind of sugar, like I use dates, or some type of oil. I actually use something other than oil. So this is definitely a mixture, and it's a heterogeneous mixture because you can see the chocolate chips. All right, the chocolate chip itself is a homogeneous mixture. Chocolate is made up of lots of stuff. There is always a sugar, and there's always some kind of fat in there. It is not pure. It's not a pure substance. Cocoa is a mixture. The pure substance, we'll get to an example, and I'll show you how you can tell. When you look at a chocolate chip, you don't see all the things that are composing it, all the different things that are mixed in there, so it is homogeneous to our eyes. And it is a mixture because you can get all different types of chocolate chips. So it tells you they've mixed the things in different ways. All right. Sorry, I've been kneeling, and apparently that's the limit on my knees. So I have to get the note chair. All right. Oh, I had notes to myself. All right. Baking soda. All right, this is a pure substance, and the way you can tell at this point in the class is I give you symbols. Like here, don't try to write this out if you didn't. I don't expect that you know chemical compounds yet, but if I give you symbols and there's different types of symbols all together, you would go, well, that's a compound. That's all there is to it. So that is a chemical compound. Baking soda is sodium bicarbonate. And all right, so for D&E, do pink for the drop of blood. If we pricked a finger, saw a drop of blood, you would look at that blood with your eyes, and it is definitely homogeneous, and it is a mix. It is made up of red blood cells and white blood cells and platelets and all types of other good stuff in there. But with your eyes, it's homogeneous. Of course, if you look under a microscope, if you let it sit for a while, it does separate. But this is that first drop of blood. Hemoglobin is in your blood. It's what carries the oxygen, and it has a formula after it. That is a compound. And again, compounds are always homogeneous, so you just have to write the word compound. All right, let's go ahead and finish this list. And if you guys have questions, we're going along, you can ask. All right, vinegar. The word solution. Again, this is a lot of information, so you just make a note. The word solution means it's in water. So you have vinegar, which is actually the acetic acid in question G. Vinegar is always a mix of the acid, acetic acid, in water. So it's a mix. I have this question here because if you get the real vinegar, you can see floaties in it. That means it's the good stuff. That's called the mother. I don't fully know what that means, but I have this question here because I recognize that. I try to avoid a question like this on a quiz or a test, like the take home on, or I would accept heterogeneous or homogeneous. I also have the vinegar that's been filtered, and so it is definitely, so if it said filtered, let's go ahead and add that. Let's say filtered vinegar solution. A filtered vinegar solution will make it homogeneous. It will look the same throughout. So I am here to serve you, to help you along. I'm not here to trick you. So if you run into something like that, just ask. It means somebody else in the class has the same question, and I'm very grateful for your questions. Right, the vinegar was made up of acetic acid and water. I don't expect that you know that, but when you see this, you see C's and H's and O's. So that's a bunch of different elements. I'm gonna learn my elements. Again, you can always have a periodic table with the names on there. We're not gonna use these ones down at the bottom. First 36, become familiar with them. Anyway, carbon, hydrogens, oxygens, this is a compound. All right, we're gonna finally see an element. And that is here. I is an element, finally. Calcium. I know I skipped H, but I was so excited to finally have an element. Vitamin C, that's a compound because, again, it's a different blend of carbon, hydrogens, and oxygens. The multivitamin, it's a mix of different vitamins. There are now millions of vitamins and essential nutrients. The best way to get them is to eat real food. When you get them in a pill, they don't work the same way as they do when you get them in real life. But the multivitamin is a mix. I'm going to put a question mark on mine. Depends on your multivitamin. Some people's multivitamins are heterogeneous and some people's are homogeneous. And so I recognize it. You do need to know, though, it's definitely a mix because every vitamin, that's why you get on the side, it tells you what's in there and how much. And everybody's vitamins are different amounts of them. So my question is with calcium. Does anybody know the symbol for calcium? What number it is on the periodic, or yeah, what the symbol is? And it's okay, none of you need to know it yet, but you should become familiar with it. Go ahead.
Isn't it CA 20?
It is. It's number 20. So something you might want to do is, and again, if I didn't post one, I will post one that you can print that will have the names little. I love this one from OMSI. I was using it last night. Because it has just too much information. I also have this one. People give me lots of fun periodic stuff. I actually have a huge periodic table of this that somebody gave me. There's a book sitting in my office, and because I usually hand it out for the students to look at, that this guy wrote about each of the different elements, and it just has a picture of each one of them and a use of it, which is pretty cool. All right, are there questions about that, about what we've covered so far? The study set is for Tuesday. I will post it if not today. Today's a really busy day for me, and so it will be there by Thursday. The sun is out, and so I don't know what will happen on Wednesday, but it will definitely be there by Thursday morning. It is due next Tuesday. The first study set for many people doesn't take that long, so there'll be a page of these things and a little bit of fine-tuning. Study set is due at 10 a.m. that you upload it before the class. I am looking that you made your best effort on it, and then I'll go over it, and so you'll self-grade it, and then I will post my answer key, so if you missed anything as I was going over it, you can check it again. So my answer key will show up. If you turn it in late, it does lose a point because you, and don't just copy my answer key. This was something I didn't mention. It says it on the syllabus. I take late assignments until the midterm, the celebration of learning, and then we move on. And that is true for labs and study sets. And that will also be true the take-home quizzes and stuff. They lose a point for being late. There's also a point or 2 points a week for showing up. Whether it's office hours, whether it's participating in lecture. If you're somebody who knows you can't come Thursday, then just be here Tuesday for the whole shebang, and I'll be good with that. You need to have contact with me more than 30 seconds or not at all. I had students, this is chemistry, and they never came. And they did pass the class, they turned stuff in, but they turned in crap. And they just weren't, and the students who came to office hours, a lot of students came to office hours and they said they just sat and listened. Sitting and listening is beautiful. Sitting and just copying what the other people did, that's not going to help you. So sitting and listening to help it trigger a thought. All right, and I'm going to move on if there's no questions. All right, I actually recorded this page as Tinkerbell because it's really hard for me to take this whole world seriously, that I'm in this virtual world now. And also sig figs, they're really tedious. And so if I'm Tinkerbell, I can teach them much better. So this is for, you can watch it at your leisure. It takes me about a half hour to go through it. And then if you have questions, and there are questions on your homework for next Tuesday. Again, Tuesday and Thursday, I'll be here from 9 to 10 that I can answer one-on-one questions. So you just have to watch it before Tuesday, before you do your homework. So I'm going to move on to the third page. And we're probably just going to do this top one, and I'm going to do this page more on Thursday. So it'll take me probably, yeah, and we'll also look at this page as practice. It says practice for the quiz. Again, I'm going to do them as take home, but it will be somewhat like this. So you can see you're going to be circling stuff, saying if it's a mixture, chemical, physical, and then there'll be some sig fig questions and stuff. All right, so what we're going to segue into is the math. How chemists do math. Periodic table has numbers. It's all about numbers and symbols. It's applied math. It's wonderful. It's why we do math, and one of the many reasons. Your lab, which is due Thursday, and it's due by 11:59 p.m. So Thursday, before it hits midnight on Thursday. I was going to say before you go to bed, I know the other thing I forgot to mention. What I learned this summer is a lot of students wait till the last minute to do things. And it's not just you, it's in all the classes. And all the teachers made this 11:59 deadline. And Blackboard gets overwhelmed at 11:58 at night and can take a long time to upload. If your assignment, if it's taking a while to upload, I recognize that. If it shows up at 12:01 on Friday morning, I'm not going to mark it as late. If it shows up at 1:01, I'm not going to mark it as late. I recognize things happen. I had a student who hit submit and then she went to bed, and the next morning she realized it was just still sitting there. And she sent me an email. So if you do this every single time, we're going to have a conversation. But yeah, don't panic if something's like a half hour late or something. All right, it will all work out. Just say, you can actually type me a note in the Blackboard saying, hey, it was one of those days, sorry it's a half hour late. If it's a day late, you lose the point. If it's an hour late, we're cool, everything's fine. We're going to talk about metric because it is on the lab. The lab has 4 pages. Sorry, my organization being at home. So one of the pages looks like this, and you're going to do conversions. Oh, look at that. One of the pages is about the elements. So it gives symbols and you write the names in. If you don't have a printer, just do it the best you can. You don't have to make everything in boxes, just you'll be fine. And there are 2 pages or watching a video and just writing a paragraph or matching, and you'll be fine. Just do it. We're going to talk about metric. So in the past, I would tell you, you have to know this. It has to be in your brain. You're not going to get this cheat sheet on an exam. So we're in a whole different world now, and I have to accept, you guys, once your exams are going to have a time limit, you do want to make like a page that's going to have the pieces, the notes that you're going to want, and probably the metric system is going to be one of the things. These are prefixes that we use in the metric system. The base unit can be, there's so many possibilities. It can be grams, so G is for grams. It can be L, which is liters. It can be M, which is meters. It can be seconds. The abbreviation for seconds is just S, but most people, when they write S, they think it's a 5. It's actually reading your own handwriting. I actually can read most of your handwriting better than you read your own sometimes. And then you end up typing it in your calculator with a 5. All right. Actually, some chemistry unit, moles are a base unit. Molarity, there's a whole bunch of pascals. We're going to mostly, though, deal with grams, liters, meters, seconds. So that is your base. And what happens is you can put a prefix before it and a prefix after it. I'm going to switch to the green. And these prefixes, kilo, mega, giga, tera, they make you have something that's really big. You have a lot of it. So kilo is 10 to the third, mega is 10 to the sixth, giga is 10 to the ninth, tera is 10 to the 12th. It's 1,000-fold. And we do it in scientific notation. This is just how many zeros. So it's 1 times 10 to the third. This is a comment. This is why I have office hours. And again, I do have them Tuesday evening, and I can be here Thursday evening. And if I didn't put the link on our website under, I will add it today, or send me an email and I'll add it into our Blackboard, so you can just click on it if you're somebody who wants to come and see me like from 6 to 7 in the evening. If you don't know how to use scientific notation, Tinkerbell teaches you it in her video. We go through it, and there's some homework. We use scientific notation in chemistry. This just means there's 1,000, a million, a billion, a trillion, and it keeps going. It actually goes, this is in the lab, it goes beyond this. These two, deca and hecta, nobody uses them, so you don't really need them. So tera, it actually goes peta, exa, and then there's an A, I think it's ano. Maybe it's zeta, I can't remember, but it keeps going and going and going by 1,000. This is why we use scientific notation. Writing this number out and making sure you have 18 zeros for exa, that is a little bit ridiculously crazy. If I'm having to sit there and count to make sure you have 18 zeros, or anybody's having to do it, you want to put in scientific notation. So your calculator can do that for you. And that's why on Thursday, I also have an office hour after I go through lecture. The lecture on Thursday, sometimes we get done early. And so I will have an office hour after until 1 o'clock. And so I can also help if you can't, if you're somebody who doesn't like 9 o'clock, it's not going to work for you. A lot of you are pretty young, and 9 o'clock may or may not work. All right, these guys down here, so deci, centi, milli, micro, nano, pico, and it keeps going. They are less than 1. They're small. And so they have a negative exponent. And I'm going to go back to this here. So I want to talk about milli. When you are taught this you're actually taught this in kindergarten, in 1st grade, you don't know that there's numbers less than 1 yet. So the way they teach it is they'll say milli, there's 1,000 millimeters in a meter. The actual, what this is, and every chart I found online was doing it this way, and this is how chemists teach it, is how this chart works is 1 of the prefix equals 10 to the power of the base unit. And since you guys are going to be able to either print or rewrite the chart when you do all of your work, including on exams, because they won't let us be together for some reason, because we all have cooties, right? That's how you would do it. So if we're doing milli, we would say 1 milligram. So it has to always have something with the prefix. So milligram, milliliter, millisecond equals 10 to the -3 grams. So this base would be grams. What that means, you could also write it as 0.001 grams. You don't have to be writing all this down, sorry. Everybody has a different way of thinking about this. I recommend, Tinkerbell talks about it, depending on your major. So I can't remember who was my pharmacy major, and my nursing major, they will actually mark you wrong in nursing school if you don't put the 0 before the decimal. A couple of you are going into chemistry or engineering. We usually leave that 0 off. We just show the decimal. It's like, why do we need it there? It's just a placeholder. I recommend you learn how to do it in scientific notation and you're comfortable with your calculator. It becomes so much more efficient. Now, how you're taught it in elementary school is there's 1,000 milligrams to 1 gram. That is the same thing I just said. What happens here is you're defining the gram by saying how many milligrams fit into it. What I'm doing over here with this chart is I'm defining the prefix always. A milligram is 1,000th of a gram. Now, if you're somebody who has used metric really well and you're awesome at metric and you want to do it as 1,000 milligrams in a gram, go for it. If you can do it correctly, that's what I care. I am going to do it how the chart is. I can do it both ways. I actually flip back and forth depending on my brain, what part I'm using. All right, what I'm going to do now, you probably want just scratch paper. I am going to show you how the chart works with this first question on the lab. There's different ways you can do this. I'm going to show you 2 different ways, and you can pick the way you want for this assignment. The one way is something that I'm going to talk about more on Thursday, but I wanted to show you in case you want to do the lab and just to have it done before class. It is something called unit conversions. That's what the rest of this page is about that I'm going to talk about on Thursday. Sorry, I keep forgetting what day of the week it is. And again, if you can't be here on Thursday because you scheduled work on Thursday, that's fine. I will videotape it. Just always be here on Tuesday, or I'll be Thursday evening. I can be here. What you do, this is unit conversions. I'm going to do it more on Thursday, is you take the unit you're working with, which is kilograms, and we're doing metric here, so you get rid of the K and you go to grams. And then your next step, you take this unit, grams, and you bring it down. And now I'm going to change to milligrams. So whatever unit you start with pulls down. What that means is that unit would cancel, and then your grams would technically cancel, and you'll have milligrams. So it's something called unit conversions. It really rocks. It's something that chemists use for doing math with the periodic table. We're going to be doing this for the next, the first 2 weeks. We do a lot of math before we get to the periodic table to refine our skills. And some of you love math. You all love math. Math is amazing. Numbers are comforting. Positive affirmations. Keep the vibrations good. All right, how the chart works. You put the 1 with the base unit. So the kilo and the milli get the 1. Sorry, I went off screen. And then we see that kilo means 1,000 or 10 to the 3rd. Again, if you initially want to write all the zeros, you can. And milli means 10 to -3. And then you would punch it in your calculator. Or you can say this flips to the top. This is something Tinkerbell talks about. This would be 42 times 10 to the 6th. You want to always have a unit. That is not scientific notation. Can anybody tell me what's wrong with my answer? Let's make this a bonus point. My answer, the number is correct, but that is not scientific notation. So scientific notation means you have a decimal and you only have 1 digit, not a 0, 1 non-zero digit to the left of the decimal. I don't have a decimal here. My decimal must be after the 2. This is not scientific notation. So I have to move my decimal 1 place over, which is going to add another digit here. So this is going to be 4.2 times 10 to the 7th. And right, so I mentioned you can do it, you can show your work, you can try it this way. And we're going to do more practice with this on Thursday and actually next Tuesday. And then the lab next week is all just doing this. There's no videos and, well, right, that's the plan right now. There's another way to do this one, and I want to show you. It's a really cool trick, and it works if you use the chart. I know what I wanted to say. I had a student like 5 years ago, and she told me she did not like my chart. She did not like my negative exponents, and it turned out it probably had to do with she learned about negative exponents when puberty was happening back in middle school, and she just never learned it. But she got really angry at me. Anger is not going to help either of us. So if you are not digging these charts, I can help you do it a different way. But this, when I Googled it, this was every chart that I found was using these now. And since you get to use the chart, I'm going to do it this way. Just be consistent. Most students find that this really rocks for them, especially if they ever had trouble before. All right, there is a trick you can do with the chart, and you can get around doing all of this. It works only when we're doing a metric to metric, one dimensional. If you do, you take your starting exponent, and again, there'll always be like 2 people in the whole class who like this trick. This is how your teacher can look really smart up in front of the classroom, is I learn all these ways. And this is your ending exponent. And you always subtract them. And the reason it works is if you know your math and exponents, when an exponent's in the denominator, you subtract it. So 3 minus -3, we got the 6. So you would just say you're going from 3 to -3, so 3 minus -3, you would get to 6. And then we had to move our place value over 1. I can show you on the next one, or we can make up a different question. I'm going to show you on the next one, but I want you all to make sure I'm doing the first 2 problems for you on this lab. Please try them on your own to make sure you can get them. And if you're not, say, hey, I need help. I got to figure out when she's in office hours, and that could be this evening at 6 o'clock. That could be Thursday before class. That could be Thursday after class. That could be Thursday evening. I also have other options on Wednesday and Friday. Just talk to me. All right. If we're going to do the shortcut, Pico is -12. Millie is -3. She would take -12 minus 3, which means plus 3, and we would get -9. So showing it in scientific notation, this was already 4.2. And you can show it as 4.2 times 10 to -9. I wanted to show this because there's always half of you like this. I actually prefer that myself. In my 200 class, some of you will be with me. We move on to 221 next term. That's how I always write it. It has to be a capital E. Little e means something else. These first 2 weeks are it's working out some of the kinks to get us into the heart of the periodic table. And so 4.2 e to the -9. I'm going to also show it doing it the factor label, just to show you it again. So I'll take this one down here. And so if you write really small, you can show your work on there. You can show it as the exponents. You might have another way. Some students like doing the counting way. You can do that. That's really what the problem with the counting way is some of the charts are sideways and some are up and down, but if that works for you, you can do that. We would have, 4.2 PG. P stands for Pico. I recommend if you are somebody going into science or engineering that you want to fill, and nursing, the first exam you have in nursing school is feeling comfortable with this math that we're going to be doing over the next week. And my students always send me emails saying, thank you so much. I really didn't know what you were doing, but over these 2 weeks, we are going to do so much with this that by the end of 2 weeks, into the 3rd week, you're going to be like, I've got this, and you're going to be a master of it. All right. So we pull the PG down. the unit, and we write the new unit on top, just the G. This requires 2 steps. Once you master this, it becomes super fast. I am going to MG. So I write my units in. This unit pulls down, goes to a new unit. This unit pulls down, goes to a new unit. This piece holds true by itself. This is called a factor. And this is what we're going to do on Thursday. All right. Using my chart. It's not my chart. I plagiarized it off the internet. Look at that. And I even put a little note here how to use it. This is from the lab when you print it. You put a 1 with the base unit. So there would be 1s there, 1 nanometer, 1 micro. This is micro. I need to mention that before we go on, before I dismiss you. And then gram, if you look up pico, it's 10 to negative 12. Milli is 10 to negative 3. What this chart does is it gets rid of the issue of kilo being 1,000 and milli being 1,000, because milli is no longer 1,000. Milli is now 1,000th. Anyway, we punch it in and you will get my answer up there. So that's, for some of you, this is on the lab for Thursday, because we need to get practice. We're going to work on it more on Thursday, but I have office hours. 2 things I want to point out about the chart, because I recommend you just learn it and you can do it without the chart. The large ones you guys actually all know, because it has to do with like kilobytes. We're all out of kilobytes anymore, but megabytes, gigabytes, we're into tera, and actually we're up to petabytes. Peta, I don't know. These 3 here, micro, nano, and pico, they actually are used a lot in like the biological sciences, going into the micro world. They are alphabetical. That's a really awesome coincidence, but they're M, N, and P. There are so many M's that micro is a mu. It's a Greek letter. What happens is people can't read other people's handwritings, and in pharmacy and nursing, they killed some people because they gave a dose that was supposed to be a microgram and they thought it said milligram. So make sure that you can read the handwriting. Some of your printers are not going to know what the symbol is, and they're going to put a little box. You can always pull it back up on the screen, or if you're looking at the screen, it's going to know it. There is another symbol for this, and it is MCG. That means micrograms. You can also always write the unit out. And it is because dosing is usually in grams, so you'll run into that. You'll see me use it. Oh, I wrote it up here. You can write it either way, micrograms or MCG is micrograms. All right. Yeah, and on the chart, I give a thing here, a zettabyte. It's a real thing, so you can just Google it and find out. They'll give you the exponent, because that's how everybody talks about this. Any questions? That was a lot of information for the first day, but you know what? Now you feel like you're really in school. We had a whole extra week off. That was awesome.
Yes, I have a question. So are we doing Zoom Tuesdays and Thursdays?
Yeah, I'm going to stop my share so I can see you all. I am doing Zoom Tuesday and Thursday. I highly recommend that you also make this time available, because I have found the students who are able to be with me both days. However, in the schedule, it does only say one of the days that you have to be here. So like the exams are mandatory. Yeah, I don't know who asked the question. I hope that answered your question. I am going to be here Tuesday and Thursday. You have labs due on Thursday, so I recommend you find time to be here on Thursday. And again, when I did this in the summer and the spring, the students who made the time to be here when I was here doing my taping my lectures, they will be taped and posted. They did better because they were present. And actually, the top student who got 103% this summer, he was always here. He just took notes. He did all of his homework. He never copied anything. He came to every office hour. It was crazy, but it was really fun. But he also re-listened to all my lectures, even though he took the notes already, so that he felt like he fully got all the pieces. So like over the weekend, he listened to him again. So yeah, thank you for the question. Anybody else have a question? I'm going to. Okay. There we go. I am recording. I'm going to stop.